Chapter 2, Exercise 2.12, one more questions. Question number 1, integral 1 by x cube into dx. This is in the form of 1 by x power n dx. Integral 1 by x power n dx. That is equal to minus 1 by n minus 1 x to the power n minus 1 plus c. By use of this formula, which is equal to minus 1 by n minus 1 2 x power 2 plus c, minus 1 by 2x square plus c. The option is B. For question number 2, integral a power x dx, this 2 power x dx, that is in the form of integral a power x dx, that is equal to a power x divided by log a plus c. Here we have a as 2, substituting a equal to in this formula, a power x, 2 power x divided by log a, log 2 plus c. That is option number C is the correct answer. Now question number 3, sin 2x by 2 sin x is given. Sin 2x by 2 sin x. For sin 2x we have formula, sin 2x will be equal to 2 sin x cos x. We have equal formula for sin 2x, 2 sin x into cos x. So substituting in the numerator, 2 sin x cos x divided by the denominator is 2 sin x. So 2 sin x get cancelled, remaining is cos x. So here which is equal to sin 2x by 2 sin x equal to cos x. So cos x dx. Can simplify this, then only you can apply formula. We don't have direct formula to integrate the problem number 3. So here simplify by using the trigonometric formula and then integrate. Now integral cos x. Integral cos x is equal to sin x plus c. So it is equal to sin x plus c. Now question number 4. Here we have one more formula. We need one more formula to complete this. The numerator in the form of sin c minus sin d. We have learned in 11th standard there is a formula sin c minus sin d, that is equal to 2 cos c plus d by 2, 2 cos c plus d by 2 and sin c minus d by 2. Here is a formula for sin c minus sin d. We have learned in 11th standard. Sin c minus sin d equal to 2 cos c plus d by 2 and sin c minus d by 2. Sin c minus 2 cos c plus d by 2, sin c minus d by 2. Substituting here, the numerator return as integral sin c 2 cos c plus d by 2. 5x is c and x is d. So 2 cos, you can simplify here, then we can apply, which is equal to 2 cos c plus d, 5x plus x, 6x by 2 and sin c minus d by 2, 5x minus x, 4x by 2. Cancel these 2, 3x, here by cancelling 2x. So it is equal to 2 cos 3x sin 2x. 2 cos 3x sin 2x. But in denominator we have cos 3x. So cos 3x and cos 3x are eliminated. Remaining is 2 sin 2x. So integral value of this simplified form of sin 5x minus sin x by cos 3x will be equal to 2 sin 2x. 2 sin 2x into dx. Are you clear? Listen carefully. The numerator in the form of sin c minus sin d. Instead c we have 5x. Instead d we have x. Now substituting these two in the formula of sin c minus sin d. 2 cos c plus d by 2 sin c minus d by 2. C is 5x, d is x. So 5 plus x by 2, 6x by 2 is 3x. 5x minus x by 2 is 4x by 2. Simplifying this, here 2 cos 3x sin 2x. The denominator we have cos 3x. So cos 3x eliminated. Remaining is 2 sin 2x. 2 sin 2x. By integrating, here cos x is sin x. By sin x, integral sin x is minus cos x, which is equal to 2 into, for integral sin ax. Integral sin ax we have formula minus cos ax by a plus c, or minus 1 by a cos ax plus c. Here substituting in it, minus cos 2x divided by 2 plus c. Can cancel the 2 here. So minus cos 2x plus c. Minus cos 2x plus c is the answer for question number 4. Look at here, for the first one, 1 by x cube dx, by use of the formula integral 1 by x power n dx minus 1 by n minus 1 x power n minus 1, substitute n as 3 here, 2x power 2 minus 1 by 2x power 2 plus c. The second case, this is also by direct formula, integral a power x dx is equal to a power x by log a plus c. Instead a substitute 2, so 2 power x by log 2 plus c. For the third case, substituting the equal trigonometry formula for sin 2x, we have sin 2x is equal to 2 sin x cos x, and in denominator we have 2 sin x. So 2 sin x get cancelled, remaining is cos x. So after simplifying sin 2x by 2 sin x, we get a cos x. So we can integrate only cos x. So integral cos x dx is equal to sin x plus c. Integral cos x we have direct formula sin x plus c. And fourth one, the numerator in the form of sin c minus sin d and divided by cos 3x. The sin c minus sin d formula is 2 cos c plus d by 2 sin c minus d by 2. Instead c substitute 5x, instead d substitute x. So sin c minus sin d will be equal to 2 cos 6x by 2 sin 4x by 2. By cancelling by 2 here, 2 cos 3x and sin 2x. The denominator we have cos 3x, so cos 3x and cos 3x get cancelled, divided by cos 3x. So cos 3x get cancelled, remaining is 2 sin 2x, 2 sin 2x. So for we have integral formula sin ax is equal to minus cos ax by a plus c. So substituting here, this 2 is kept here, the remaining integral sin 2x is minus cos 2x by 2, cancelling the 2 plus c, we have minus cos 2x plus c. Now we are moving to the fifth question. Now question number 5, integral log x by x into dx at x greater than 0 mentioned here. Integral log x by x. Look at here, log x by x can be written as 1 by x into log x. So integral dx is equal to 1 by x, integral 1 by x log x dx. Now put t equal to log x, put t equal to log x, and dt equal to dt equal to dt by dx is equal to 1 by x dx. So dt equal to 1 by x dx. Differentiating we have dt equal to 1 by x dx. Substituting the above, log x is t, the remaining 1 by x dx are dt. By integrating, exponent formula t square by 2 plus c, that is equal to, instead t we have log x, so log x whole square by 2 plus c. So by integrating, log x by x dx yields 1 by 2 log x whole square plus c, or log x square by 2 plus c, log x whole square by 2 plus c. Now our textbook option A is correct. 1 by 2 log x whole square plus c. Now question number 6, integral e power x divided by root of 1 plus e power x dx. Here we have another formula, integral f dash of x in the numerator, then the function root of f of x in the denominator, dx, we have formula 2 times root of f of x plus c. The function within the square root of the denominator, the function's derivative appears in the numerator. Here root of f of x, here we have f dash of x, derivative of f of x in the numerator. We have formula 2 times root of f of x plus c. So it will be equal to, here 1 plus e power x, taken f of x, its derivative f dash of x is 0 plus e power x, that is e power x, which is in the numerator. So this is in the form of f dash of x by root of f of x dx. We can go with the formula 2 into root of f of x plus c. So it is equal to 2 times root of f of x is 1 plus e power x plus c. Or we can simplify it, 2 into 1 plus e power x whole power half plus c. Both the way we will be expect the answer 2 into root of 1 plus e power x plus c, or 2 into 1 plus e power x whole power half plus c. Both the way we can expect the answer. Now question number 7, root of e power x dx, square root of e power x dx. So it can simplify into integral e power x whole power half into dx. Can multiply the powers, which is equal to integral e power 1 by 2x dx. Now we have converted the form of integral e power ax dx, that is equal to e power ax by a plus c. Now substituting here, this is e power 1 by 2x divided by 1 by 2 plus c. Again we can simplify this 1 by 2 into root of e power x plus c. 1 by 2 root of e power x plus c. Next one, question number 8. Integral e power 2x, 2x square plus 2x is given, which is in the form of integral e to the power, integral e power, this is constant appears here. So by constant appearing we can take it as ax into 2x square plus 2x, here ax, here a into f of x, and its derivative f dash of x. Here is a separate form. This is in the form of e power ax, a into f of x. This is taken as f of x and plus f dash of x, derivative f dash of x. Here we can go with the formula. There is a formula, that is e power ax into f of x, e power ax into f of x plus c, e power ax into f of x plus c. Substituting in it, which is equal to e power 2x into f of x, x square plus c. E power 2x into x square plus c is the answer for question number 8. Question number 9. Integral e power x by e power x plus 1 dx is given. Here, what is the derivative of e power plus 1? The derivative of e power x plus 1 is e power x. So, if you are taken denominator as f of x, the numerator is f dash of x into dx. That is, f of x is equal to e power x plus 1. Its derivative f dash of x is equal to e power x plus 0 equal to e power x. So the given problem 9 is in the form of f dash of x by f of x into dx. We have formula for this, log of modulus of f of x plus c. So applying the above formula, we will get log of modulus modulus of e power x plus 1 plus c. So it is equal to log of modulus of e power x plus 1 plus c. Log of modulus of e power x plus 1 plus c. Now question number 10. Look at here. 9 by x minus 3 minus 1 by x plus 1. 9 by x minus 3 minus 1 by x plus 1. Here we can separate and integrate, which is equal to 9 into integral 1 by x minus 3 dx minus 1 into integral 1 by x plus 1 dx. We can separate the integral for the two different functions. Here this is in the form of integral dx by x minus a or x plus a form or ax plus b form. Can taken as here a is 1, b is 3, which is equal to 1 by a log modulus of ax plus b plus c. We have formula for integral dx by ax plus b equal to 1 by ax plus b into dx is equal to 1 by a log of modulus of ax plus b plus c. Here a is 1 and b is minus 3. Here a is 1, b is 1. Here we are substituting in the formula. For the first one we have 9 into 1 by a. Here is 1 only, 1 by 1 is 1 log of modulus of ax plus b, that is x minus 3 minus 1 by a. Here a is 1, 1 by 1 is 1 log of modulus of ax plus b, that is x plus 1 plus c. You can simplify these two as log of log a minus log b. We cannot simplify because here we have 9, there we have minus log, here 9, here we have minus log. So it is it can simplify it when we take this one to the power, and then we can simplify. But our answer in the text is for question number 10. They have left it here itself 9 into log of x minus 3 minus log of x plus 1 plus c. So you can leave it here itself. So the answer for integral 9 by x minus 3 minus 1 by x plus 1 dx is equal to 9 into log of x modulus x minus 3 minus log of x modulus x plus 1 plus c. Option number C. Now question number 11. Integral 2x cube by 4 plus x power 4 dx is given. Look at the denominator 4 plus x power 4. Differentiate it. 0 plus 4x cube. Listen carefully here. F of x is equal to 4 plus x power 4 is taken. Then f dash of x is equal to 0 plus 4x cube. But here we have only 2x cube in the numerator. So we can just adjusting the result given question equally. So multiply by 2, it will turn as 4x cube, and divide it by 2. Then keep the same denominator here. Now we are in the form of, this is in the form of 1 by 2 integral f dash of x divided by f of x dx. Look at the above formula. Integral f dash of x by f of x dx is equal to log of modulus of f of x plus c. So the term is equal to f dash of x by f of x dx integral. So we can substitute this equal formula log of modulus f of x plus c, which is equal to 1 by 2 log of modulus of f of x is nothing but 4 plus x power 4. 4 plus x power 4 plus c. So for question number 11, answer is 1 by 2 log of modulus of 4 plus x power 4 plus c. Option number B. And now question number 12. Question number 12, integral dx by root of x square minus 36. This can be rewritten as integral dx by root of x square minus 6 square This is in the form of integral dx by root of x square minus a square dx. X square minus a square. We have formula for this. This is equal to direct formula we have here. This is equal to log of modulus of x plus root of x square minus a square plus c. So substituting in the above formula we have log of modulus of x plus root of x square minus 6 square, that is 36, plus c. This is option number, in question number 12, option number B, log of modulus of x plus root of x square minus 36 plus c. Now question number 13, integral 2x plus 3 divided by root of x square plus 3x plus 2 into dx. Now look at the denominator. The function within the square root is f of x is equal to x square plus 3x plus 2. And its derivative f dash of x is equal to 2x plus 3. Look at the numerator. The derivative of the f of x presents in the numerator. So this is in the form of integral f dash of x divided by root of f of x into dx. For this we have formula 2 times root of f of x plus c. So substituting in the above formula here, which is equal to 2 times root of f of x is x square plus 3x plus 2. So here, which is equal to 2 times root of x square plus 3x plus 2 plus c. So question number 13, the option is B, 2 into root of x square plus 3x plus 2 plus c. Now question number 14, integral 0 to 1, 2x plus 1 into dx is given. This is simple. Integrate the function 2 into x square by 2 plus x. Apply a lower and upper limits. Can cancel the 2. Applying upper limit 1 square 1 plus for x 1 minus substituting 0 0. So 2 minus 0 equal to 2. So for question number 14, the answer is option B, answer 2. For question number 15, integral 2 to 4 1 by x dx is given. Integral 1 by x dx is equal to log x, log of modulus x, limit is given 2 to 4. Now substituting upper and lower limit values, which is equal to log 4 minus log 2. Both are positive, its modulus also same value, log 4 minus log 2. So log a minus log b equal to log of a by b, log of 4 by 2 equal to log 2. Equal to log 2. Therefore, the 2 to 4 1 by x dx is equal to log 2. Next one, question number 16. 0 to infinity e power minus 3x dx is equal to. Now this is in the form of integral e power minus ax dx. For this we have formula e power minus ax divided by minus a plus c. So substituting the formula here, we have e power minus 2x by minus 2 limit 0 to infinity. E power minus 2x by minus 2 limit 0 to infinity. Now substituting the upper and lower limits, minus 1 by 2 is taken out. The remaining are e power minus infinity minus e power minus 0, which is equal to minus 1 by 2 into e power minus infinity is 0. Then again minus e power minus 0 is minus 1, that is equal to plus 1 by 2. Therefore, the answer for the question number 16 is plus 1 by 2. For 15th we have log 2. Now question number 17. Look at here. This is in the form of minus 1 to plus 1 f of x dx. Minus 1 to plus 1 f of x dx. For whenever the limit are equal, then starts from minus to plus, we can check by the property of integral. The function is either odd or even. So by checking the function is odd or even, we can conclude the result directly. So f of x is equal to x cube e power x power 4 is given. Replace x to minus x. Then f of minus x is equal to minus x whole cube e to the power minus x power 4. Here minus x cube e power x power 4 again. That is equal to minus of f of x. So the given function f of x is odd function. So directly we can write the answer minus 1 to plus 1 x cube e power x power 4 dx is equal to 0. Then look at the 18th question. This is one of the property. Integral a to c f of x dx plus integral c to b f of x dx. C lies between a and b, and f of x is continuous in the whole interval a to b. Then we can rewritten as integral a to b f of x dx. This is one of the property is given as a question. So integral a to c f of x dx plus integral c to b f of x dx equal to a to b f of x dx when f of x is continuous in the entire interval a to b, where c is the particular point between the limits a and b. Question number 19. The value of integral minus pi by 2 to plus pi by 2 cos x dx is given. Here minus a to plus a appears. So we should check the function is either odd or even. F of x is equal to cos x. So cos x is an even function always. So it can be written as 2 times integral 0 to a f of x dx. If f of x is even, integral minus a to plus a f of x dx is equal to twice integral 0 to a f of x dx. We have formula. Now the property is this. Now substituting this property, we can write as twice 0 to pi by 2 cos x dx. For integral cos x, we have formula sin x. Limit 0 to pi by 2. Substituting the upper and lower limit values here, 2 into sin pi by 2 minus sin 0. So sin 90 is 1, then 1 minus 0, that is equal to 2. So the answer for question number 19 is option B, 2. And question number 20 here. Given integral limit 0 to 1 root of x power 4 into 1 minus s whole square into dx. Now after taking the square root, both are perfect squares. We can take square root integral 0 to 1. This is x square into 1 minus x dx. Now multiply inside integral 0 to 1 x square minus x cube into dx. By integrating x cube by 3 minus x power by 4 limit 0 to 1. Both are in the form of exponent formula. Integral x power n dx is equal to x power n plus 1 by n plus 1. Here also x power n plus 1 by n plus 1. Substituting upper and lower limit values. By substituting upper limit 1 by 3 minus 1 by 4. By substituting lower limit, both the term includes x, therefore both become 0. So simplify this. 4 minus 3 by 12 is equal to 1 by 12. 4 minus 3 by 12 equal to 1 by 12. So the option is A, 1 by 12, which is equal to 1 by 12. மதியம் கொடுத்தா வந்து பரவாயில்லைங்கிறாரு. மதியம் கிடைச்சா பரவாயில்லைங்கிற மாதிரி சொல்றாரு. நம்ம போய் தான் வாங்கிட்டு. Now 21, if integral 0 to 1 f of x dx is equal to 1, 0 to 1 x into f of x dx is equal to a, and integral 0 to 1 x square f of x dx is equal to a square, then integral 0 to 1 a minus x whole square f of x dx is equal to dash is given. Given 0 to 1 f of x dx is value 1, f of x dx value is a, and 0 to 1 x square f of x dx value is a square. Then find value of 0 to 1 a minus x square f of x dx. We can, by expanding integral 0 to 1 a square minus 2ax plus x square into f of x dx. Here f of x into f of x dx into f of x dx is equal to, separating this one, integral 0 to 1 a square f of x dx, a square f of x dx, here minus 2a into integral x f of x dx plus integral 0 to 1 here, 0 to 1 x square f of x dx, square f of x dx. Now substituting the above values, a square into f of x dx is 1 minus 2a into x f of x dx is a plus 0 to 1 x square f of x is a square. So minus 2a square plus 2a square equal to 0 is the answer. Question number 22, integral 2 to 3 f of 5 minus x dx minus integral 2 to 3 f of x dx. We have property integral a to b f of x dx will be equal to integral a to b f of a plus b minus x dx. Now look at here, a to b f of x dx. Look at this one now. A to b f of a plus b is 5 minus x dx. So these two results are equal. When we subtract, they are become 0. So here, look at here, a to b f of x dx is 2 to 3 f of x dx, and a to b f of a minus dx is 2 to 3 f of 5 minus x dx. These two are equal. When subtraction, it yields answer 0. Now question number 23, can integrate this equal to, here x power 1 by 2, for x power 1 by 2, x power 1 by 2 plus 1 by 1 by 2 plus 1, plus here minus 1 by n minus 1 minus 1 by 2 x power minus 1 by 2, limits 0 to 4. Simplifying this, we will have 2 into x power 3 by 2 by 3 minus 2 into minus minus become plus 2 into 1 by x power minus 1 by 2. Here substituting upper and lower limit values 0 to 4, we have 2 into 4 power 3 by 2 is 4 power 1 into 4 power half, 4 into 2 equal to 8, 4 power 3 by 2 is 8, 2 into 8 by 3 plus 2 into, it can be written as x power 1 by 2, so 4 power 1 by 2 is 2, and substituting the lower limit both become 0, and here which is equal to 16 by 3 plus 4 which will be equal to 16 plus 4 3s are here 12 by 3 equal to 28 by 3, which is equal to 28 by 3. Option C, 28 by 3. Here, bring this denominator numerator and keep it as x power half. That is easy to calculate here. Bring it as x power half. X power 1 by 2. Then you can easily calculate the value. The option is C, 28 by 3 is answer for question number 23. And question number 24, I have given one more formula in addition when explaining the integral trigonometric functions, integral for trigonometric functions. In that case, I have given integral tan x dx. Integral tan x dx is equal to, you can directly write it as log of secant x plus c or minus log cos x plus c, minus log cos x plus c. So here integral tan x is given, which is equal to log of modulus of secant x limit 0 to pi by 3. I have taken secant x here. Then substituting secant pi by 3, that is pi by 3 means 60. So secant 60. Now cos 60 is 1 by 2. So secant 60 is 2. That is equal to log of secant pi by 3 minus log of secant 0. Which is equal, here secant 0 is 1. So log 1 becomes 0. The entire value becomes 0. Now secant pi by 3 is equal to log of secant pi by 3 is 2. Cos pi by 3 is 1 by 2. And secant pi by 3 is 2. So log 2 minus 0 is log 2. So option A, integral 0 to pi by 3 tan dx is equal to log 2. Gamma of n when n equal to 8. Find gamma of n when n equal to 8. We have formula. So substituting 8 here, 8 minus 1 factorial, that is equal to 7 factorial. So 7 into 6 into 5 into 4 into 3 into 2 into 1, 42, 26 into 1 is 1. So here 42 into 120, which is equal to 5040. So here for question number 5, 5040 is the answer, option A. Option A is the right answer. And question number 26 we have gamma of n. Question is gamma of n. There are 4 options given here. In it, option A is n minus 1 factorial. We have used it in the previous sum. Gamma of n equal to n minus 1 factorial. This is the first option is the correct answer for question number 26. And question number 27 is gamma of 1. Question number 27, gamma of 1 is dash. Gamma of 1. So gamma of n equal to n minus 1 factorial, which is equal to 1 minus 1 factorial, 0 factorial. The value of 0 factorial is 1. And then that question number 28, if n greater than 0, 28, if n greater than 0, then gamma of n is, that is the formula here. We have when n greater than 0, then gamma of n equal to integral 0 to infinity e power minus x power n minus 1 into dx. Integral 0 to infinity e power minus x power n minus 1 into dx is the gamma function formula when n greater than 0, gamma of n equal to integral 0 to infinity e power minus x power n minus 1 into dx. Now question number 29, gamma of 3 by 2 which is equal to gamma of n equal to n minus 1 gamma n minus 1. Substituting in it 3 by 2 minus 1 gamma 3 by 2 minus 1, that is equal to 1 by 2 into gamma of 1 by 2. For gamma of 1 by 2 we have a result 1 by 2 into gamma of 1 by 2 is root pi, so that is equal to root pi by 2. Gamma of 1 by 2 is root pi, so 1 by 2 into root pi is root pi by 2. Option B is correct.